warm chemistry. Nice to see everyone again. And for this video, we'll talk about topic 1.1 part 2, where we will discuss isotope notation. And we will discuss isotope notation for 3 different types of particles. And they are neutral atom, your cation, and your anion. And I hope you remember that your cation is actually your positive charge ion, while your anion is your negative charge ion. At the end of this video, we will also look into what is actually isotopes. Okay, so let's move into isotope notation. What is actually notation? Notation over here is basically like the short form. Alright, we are going to learn the shorthand notation. And in this shorthand notation, in this short form, you are going to have everything that you need to know about an isotope. Okay? A general isotope notation looks something like this, where I'm using a symbol right now. You have your A, you have your Z, and also your X. So what is actually the X over here means? The X over here is actually your element symbol. So for example, if I'm using carbon, then the symbol will be C. If I'm having magnesium, then the symbol will be your Mg. That is what we mean by element symbol. For example, aluminium, then you will have your Al. Alright? Your iron over here, then you will have your Fe. So that is what we mean by element symbol. Next, what is actually Z? Z is the proton number. Z indicates the proton number of the element that we are going to write. Other than proton number, we also call this as atomic number. Most of the time, you'll be using proton number. Next, your A over here represents nucleon number. What is actually nucleon number? Nucleon number is when the proton number plus with the number of neutron. So your proton plus with the neutron will give rise to your nucleon number. Alright? So make sure you know nucleon number is obtained from the proton and also your neutron. Alright? Nucleon number will also be called as a mass number. Alright? So make sure you know nucleon number, also known as mass number. Simple. There's actually still one more thing in this shorthand notation, in this isotope notation, which is charge. Okay? This will be the location on where we write the charge. If your element right now is a neutral atom, then the charge will be 0. If the charge right now is positive, positive 1, positive 2, positive 3, so on. If the charge is positive, then it means it's a cation, obviously. Alright, your positive ion species. Last but not least, if the charge is negative, 1 negative, 2 negative, 3 negative, that means it's an anion. So the charge will be in this area. Okay? And this is the general isotope notation. This is how it looks like. Where is the position of your element symbol? Your proton number will be on the left bottom. Your nucleon number will be on the left upper, while the charge will be on the right upper. That is how we write the isotope notation. Simple. Next, let's look at the isotope notation for the neutral atom, which means there is no charge. For the cation means it's a positive charge. For the anion means it's a negative charge. For the neutral atom, it will look something like this, where your X is your element symbol, proton number, nucleon number. No charge is a 0. And since it's a 0, we do not need to write the 0. Don't write 0. Okay? Do not write the 0. While for the cation, you can see that everything remains the same, but you have the charge. And the way that we write the charge is the number comes first before the symbol. Means you'll be writing 2 positive, 3 positive. How about 1 positive? If it's a 1 positive, then we only write positive. Alright, we don't need to write the 1. Okay? Let go the 1, we just write positive. It's only positive, then we know that it's 1. Same thing applies to the anion. Everything remains the same, only the position of the charge. The charge will be Y negative. So if it's a 1 negative, you only write negative, 2 negative, or 3 negative, and so on. That is how we write the isotope notation for the neutral atom, cation, and anion. Let's look deep into the isotope notation for neutral atom. Neutral atom means there is no charge. And in what condition will it be no charge? No charge is simply because the number of proton is equal to the number of electron. This is because proton will be carrying positive charge, while electron will carry negative charge. So, it's very simple and obvious over there. If the number of proton is equal to the number of electron, then the positive and the negative will cancel off each other. For example, if I have 2 proton and then I have 2 electron. So you can see 2 positive and 2 negative will then cancel off each other. Simple. So the tips over there is when it's a neutral atom, the number of proton must be equal to the number of electron. And the isotope notation of a neutral atom will look something like this. Without the charge, do not put 0. Okay? Let's try an example. So in this example, we are going to learn how to write the isotope notation. By looking at the element, you need a few information over here. This is all the information that you need to know before you write the isotope notation. And we know that the element that we are looking at is oxygen. Therefore, the symbol of oxygen is O. So first thing, we are going to write down the O. Okay? That is the symbol of oxygen. Look at it. The tips over here is the proton number, which is 8, equal to the number of electron, which is also 8. When the proton number and the number of electron is the same, which means there will be cancel off each other. And when they cancel off each other, this means there will be neutral atom. And when there is neutral atom, no charge. Alright? So this will be the isotope notation for your neutral atom with no charge because the number of proton is equal to the number of electron. And since we know that the proton number right now is 8, the nucleon number is 16. Knowing that your nucleon is actually your proton plus with your neutron. Therefore, your number of neutron over here will be 16 minus 8, which is also 8. And the charge will be 0 because there will be neutral with no charge. So your isotope notation will look something like this, where you have the symbol O in the center, proton number sitting on the left bottom corner, which is 8. Your nucleon number will be sitting on top of it, which is 16. No charge, do not need to put 0. And this is the isotope notation for this question. Simple. Another example of question over here is isotope notation is given. From this isotope notation, you need to be able to obtain all this information. So the first thing, obviously, the element is a magnesium. Why do I know that the element is a magnesium? Because you have the Mg. Everybody knows that Mg is the symbol of magnesium. Next, we need to identify whether it's a neutral, cation, or anion. This is also obvious because from the isotope notation, there is no charge, nothing over there. Therefore, automatically, your magnesium right now is a neutral atom with no charge. In the other words, the proton number will be equal to the number of electron. And the proton number over here is 12. So put in the proton number 12. Your number of electron must also be 12 because it's a neutral atom. There is no charge. Therefore, the charge is 0. Simple. Next, on top of your proton number, that is your nucleon number. So your nucleon number over here is 24. And your number of neutron is your nucleon number minus proton number. Remember, nucleon is when the proton plus with the number of neutron. So vice versa of it, to get the number of neutron, 24 minus 12. Therefore, your number of neutron is 12. Simple? Easy. So there is two types of question we discussed over here. The first one is you need to write the isotope notation. The second is you need to understand and able to extract information from the isotope notation. Next, we are going to look into isotope notation for cation. And cation obviously is a positive charge ion. And it will become positive because number of proton is more than the number of electron. In the other words, electron is being removed. So when you remove your electron, your number of proton will be automatically higher than the number of electron. Simple, because proton bring positive charge, while electron bring negative charge. And I want the total of my charge right now is positive. Therefore, proton must be higher than electron. If my proton right now is 4 positive, my electron is 2 negative. Therefore, the charge will be 2 positive. Simple. The difference between the proton and electron will equal to the charge. And the general isotope notation will look something like this. You still have your element symbol, your proton number on the left bottom, nucleon number on the left upper, and you have the charge. What makes it different from the neutral is you have your charge on the right upper. Okay, let's go into examples. I have my element right now is aluminium. My proton number is 13. My number of neutron is 14. My charge is 3 positive. Looking at the charge 3 positive, I will know this isotope notation is cation with a positive charge, and therefore the number of proton must be larger than the number of electron. By how much? By 3 positive. In the other words, your proton right now is 13. How much your electron should be? If your proton right now is 13 positive, your proton needs to more than electron by 3 positive. So the number of electron will be 10 because 13 minus 3 equals to 10. So your number of electron is 10. And you can see over here, guys, proton right now is more than your electron by 3. Therefore, this will give rise to 3 positive. See that? Simple. The nucleon number will be the proton number plus with the neutron number. So your proton over here is 13. Your neutron over here is 14. You will give rise to 27. And since we have everything that we need, we can write the isotope notation. Isotope notation of aluminium will be starting with the symbol of Al. The proton number over here is 13. The nucleon number is 27. And the charge is 3 positive. And this is the isotope notation of aluminium in this question. Alright? Simple. Next question. You are given the isotope notation. And from the isotope notation, ladies and gentlemen, we have 2 positive given. With the charge 2 positive, again we know it's a cation with positive charge. So you can put down on the charge is a 2 positive. Next, you have your proton number given 30. You have your nucleon 65. And the element over here is your Zn, which means is your zinc. So we need to work out what is the number of electron and also the neutron. So let's work out the number of electron first. Since we know that it's a cation, therefore, number of proton, again, must be more than number of electron. Your proton number right now is 30. Alright, the charge is 2 positive. So what would be the number of electron? The number of proton right now must be more than the number of electron by 2. Therefore, the number of electron is 28. Alright, so the number of electron over here, 28. You can see the difference between that is 2 positive. Proton 30, number of electron 28, so you give rise to your charge 2 positive. Simple, easy. Tips over here. number of proton must remain the same all the time. Number of proton cannot change. The only thing that can change is your electron, because your electron right now is being removed. Electron is the only thing that we can remove or add in. Proton must remain the same. Therefore, proton is in here. Okay. Last but not least, number of neutron. Number of neutron is from the nucleon number. Nucleon number is your proton plus neutron. So, to get the number of neutron is your nucleon 65 minus proton 30. So, your number of neutron over here is 35. Okay, that is your number of neutron for zinc. Simple, easy. Last but not least, let's look into isotope notation of anion, which is a negative charge. Vice versa of the cation, where the number of proton right now must be less than the number of electron. In the other words, it's a negative charge. So your electron that carry the negative charge must be more than the proton that carry the positive charge. Okay? In the other words, your electron is gained right now or is added. Okay, you add in more electron into your atom. Therefore, the number of proton is less than the number of electron. And the isotope notation, very similar as what we had before, just a changes at the charge. The charge right now will be negative. And kind reminder, number of proton must remain the same. The number of electron is the only one that can change. Okay? You cannot add proton or remove proton. Let's look into another example. So I have the element right now is fluorine, where the symbol is F. I have the nucleon number given, 19. So the question asking for proton number of electron, with the number of neutron is given 10. And the charge is 1 negative. So when the charge is 1 negative, we know that this isotope notation is for the anion negative charge. And we know that the number of proton must be less than the number of electron. We don't have proton and we don't have electron. Which one do we find first? We always look for the proton number first. Bear that in mind. We always look for the proton number first. Okay? And the proton number will be from the nucleon number, because we know that nucleon is when the proton added up with the neutron. So right now, you have your neutron is 10. Your nucleon is 19. So your proton will be 19 minus 10, which is 9. So when the proton number calculated is 9, then only we can work out the number of electron. The proton right now is 9 with a positive. And we know that electron must be more than proton by 1. Therefore, 9 plus 1, electron will be 10. The number of electron over here is 10. And you can see the difference over here. That is your 10 negative. That is your 9 positive. Difference give rise to 1 negative. 1 negative is the charge. Simple, easy. And your isotope notation will look something like this. Started off with your fluorine, where your proton number is 9. Your nucleon number is 19. And the charge is 1 negative. Guys, when the charge is 1 negative, we only put down the symbol negative. Do not put the 1, remember. And this is the isotope notation of fluorine in this case. Another type of question where the isotope notation is given. And from here, crystal clear, is a 2 negative. Therefore, it's definitely an anion with negative charge, where we know the number of proton must be less than the number of electron. So, let's extract every information. It's an S over here, therefore it's a sulfur. Your nucleon number is 32. Your proton number is 16. Your charge is 2 negative. That is everything that you have from the isotope notation. But from all this information, we can work out the number of electron, we can work out the number of neutron. So the number of electron will be how much? Proton right now is 16. The difference is 2 minus. So electron must be more than the proton because it's a negative charge. So more by how many? More by 2. So electron must be 18. Simple. Electron right now, 18. Okay? The difference between them will give rise to 2 negative. Number of neutron? Simple. Is your nucleon number minus your proton number. So it's your 32 minus 16. Therefore, your number of neutron is 16. And that is how you understand the isotope notation of an ion. Simple, easy. Next and last part of this video will be, what is actually isotopes? Okay, isotope is 2 or more atoms of the same element, must be from the same element, that have the same proton number in the nucleus but different nucleon number. So in the other words, they must be from the same element. If we are talking about aluminium, everybody is aluminium. If we are talking about carbon, everything is carbon. Alright? And you must at least have 2. Alright? Minimum 2. And this is most important, they must have the same proton number but different nucleon number. Okay? For example, that I have hydrogen 1, hydrogen 2 and hydrogen 3 are isotopes to each other. Why I say it's isotope to each other? Because they have the same element. Everything talking about hydrogen. And that is the first condition. The second condition, look at the proton number. The proton number at the bottom over here is the same. So everybody having the same proton number. But different nucleon number. Look at the nucleon number. Nucleon number is the top number, where the nucleon number right now is 1, 2, and also 3. So you have different nucleon number over here. So when it's a different nucleon number, but same proton number, and also same element, therefore they are isotope to each other. Okay, that is how we determine the isotope. They must be from the same element, same proton number, but different nucleon number. Simple. Another example, I have sulfur 32, sulfur 33, sulfur 34, sulfur 36. So right now, how many isotopes is actually every element have? Every element will have a different number of isotopes. It's not necessarily 3, it's not necessarily 4. And the number of isotope will be very much depends on what element we are talking about. Okay? So right now, sulfur having 4 isotopes, and the isotope notation for each and every one will look something like this. The element is the same. Everybody is sulfur. The proton number also is the same because sulfur proton number is 16. But the nucleon number is different. The nucleon number between each and every one of this sulfur right now is different. Therefore, they are isotopes to each other. Okay? Next example, I have chlorine 35, I have chlorine 37. So chlorine 35 looks something like this. Chlorine 37 looks something like this. And the only things that makes them different is the nucleon number. They are still the same element, chlorine. They have the same proton number, where the proton number is 17 for chlorine. But they have different nucleon number. And chlorine right now having 2 isotopes. So for this question, we are going to group the isotope from the following. We have 6 unknown over here with their proton number given and also nucleon number given. We know that for isotopes, the proton number must be the same, but the nucleon number will be different. Since it's different, we cannot use it to identify which are isotope to each other. But we can use the proton number because the proton number must be the same. So first and foremost, I have unknown P over here having proton number 6. Look at it. I have unknown R also having the same proton number. In the other words, your P and R are isotope to each other. Alright, they must be from the same element. Next, you have your unknown Q having the proton number 12 and also your unknown T having the proton number 12. Therefore, your Q and T also isotope to each other. They must be from the same element. Last but not least, you have your S, 17 proton number, and your U, also proton number 17. In the other words, your S and U are isotope to each other. So this is one of the way that we identify who are isotope to who. Okay, we only look at the proton number first, but not the nucleon number, because the proton number must be the same. This is everything about isotope notation and isotopes that you need to know, and I hope this video able to help you in understanding isotope and isotope notation. If you like the video, make sure you hit the like button, subscribe to the channel, and share the video with your fellow friends. And thank you for watching.